Welcome to this explainer, where we are going to take your raw, messy data and turn it into absolute clarity. Today, we're targeting a notoriously tricky area of the Cambridge IT 9626 syllabus, specifically Section 14.6, which focuses on packet switching and the structure of packets. Now look, you probably know the theory inside out by now, right? You know what a packet header is, you know what a payload is, but here is the secret. Just knowing the theory, that's really only half the battle. So today, I'm going to introduce you to what I like to call the sculptor approach. We're going to take that massive, heavy block of raw knowledge sitting in your head, and we are going to learn how to chisel away the irrelevant parts, the goal, to reveal a high-scoring, precision-crafted exam masterpiece.
And I want to start with this, because this isn't just some casual study tip I made up. This is a direct quote from the ultimate authority on your grade. I'm talking about the principal examiner reports for Cambridge IT. They explicitly warn, year after year, that the absolute classic mistake students make is providing generic answers that are not specific to the question context. Think about that for a second. You could write a perfectly accurate textbook-level definition of packet switching, but if you don't directly apply it to the specific scenario given in the prompt, whether they're asking about a small local business network or a massive global data transfer, you are going to lose crucial marks. You're literally just leaving points on the table.
So here is our roadmap for today's session. We'll kick things off with the packet switching challenge. Then we'll look at the underlying IT principles. Third, we'll dive into the procedural methodology. Fourth, those critical examiner warnings you need to dodge. And finally, we'll put it all together by sculpting the perfect answer.
Let's jump right into Section 1, the packet switching challenge. So why exactly is syllabus item 14.6 such a massive stumbling block for so many? Let's look at two totally different approaches. Think of two different students taking the exact same exam. On the left side, we have our first student. Let's call him Alex. Alex does what I call the fact dump. This happens when a student panics, or honestly gets way too excited to see a topic they recognize. They just vomit every single generic fact they've ever memorized about packet switching right onto the page. They write packets of headers, they take different routes, they're reassembled at the end. Okay, true, but it's just a block of unorganized facts. Now look at the right side. This is student Sam. Sam delivers the sculpted masterpiece. Sam chips away everything that isn't relevant and applies precise definitions and causal relationships directly to the unfamiliar context. If the exam prompt is about a video streaming service, Sam's sculpted answer talks specifically about the impact of packet reassembly delays on video buffering. Top marks require you to be the sculptor, not the dump truck. Before we continue, subscribe to our YouTube channel, Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Moving right along to Section 2, IT Principles and Frameworks. The absolutely crucial point here is understanding the theoretical architecture. The syllabus is clear that packet switching doesn't exist in some isolated vacuum. It rests on precise definitions, yes, but more importantly, it relies on causal relationships and integration with other syllabus areas. The principal examiner reports explicitly highlight that candidates who reference cross-topic connections achieve significantly higher marks. For instance, don't just state that packets take different routes. Take it a step further. Connect that routing flexibility to network security by explaining how intercepting a single route only yields fragmented, completely unusable data. That is exactly how you show true mastery of the theoretical architecture. And this brings us directly to the assessment objectives. Cambridge is testing you across 3 distinct cognitive domains: knowledge and understanding, application, and analysis. Remember that fact dump from Alex we just talked about? Well, that only hits the very first domain. It completely fails the application and analysis requirements. If you merely recite rote facts about packet headers or routing tables, you are blatantly ignoring 2/3 of what the examiner is desperately trying to give you marks for. You must apply the knowledge to the scenario, and you must analyze the outcomes. Let's get into Section 3, the procedural methodology. To guarantee that we hit all 3 assessment domains every single time we write an answer, we need a bulletproof procedure. I want you to burn this concept into your brain right now. The method mark strategy. In Cambridge IT, marks are heavily awarded for the process and the execution of your analysis, not just your final presented conclusion. What does this mean for you? It means if you have a visible, logical, step-by-step process written out clearly on the page, it acts as a massive safety net. Even if your final recommendation is slightly off base, a beautifully structured argument showing exactly how you applied packet switching principles to the scenario will still secure you a huge chunk of the points. So, how do we get those method marks? Here is your 5-step chisel to sculpt that answer. Step 1. Deconstruct the question, literally decode the command words, and figure out the specific scenario. Step 2. Extract the relevant data from the prompt. Ask yourself, what are the actual constraints of the network being described here? Step 3. Select your analytical framework. Are you comparing packet switching to circuit switching in this instance? Make that choice. Step 4. Execute with clear notation. Build your argument logically, step by step. And step 5. Present with correct terminology. Don't call it a data piece, call it a packet payload. Following these 5 steps forces all that raw knowledge in your head into a highly scorable, perfectly formatted framework. Let's look at how this actually plays out in a practical framework. This table forces you to think in chains of logic rather than just isolated facts. Look closely at the transmission row. If the cause is a node failure on the network, the direct effect is path recalculation for the remaining packets. And your cross-topic link? You could tie this back to hardware limits or router configurations. If you structure your paragraphs in your exam exactly like this table, stating the action, the cause, the effect, and a cross-topic link, you are practically forcing the examiner to give you top marks for analysis. You're no longer just describing a network, you are dissecting it. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @aceexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
All right, Section 4, Critical Examiner Warnings.
We've built up your strategy, so now let's look at the top 3 ways students accidentally throw away their hard-earned marks. First up, confusing cause and effect in packet transmission. For example, stating that a packet arrives out of order because it has a sequence number. No, that's backwards. You need to correctly state that it needs a sequence number because the varying routes cause it to arrive out of order. See the difference? Second warning, forgetting to check format and presentation. If the question specifically asks for a report format and you just write a standard essay, you lose points automatically. Third, and we've really hammered this home today, failing to link your points specifically to the context. If you catch yourself making these 3 mistakes in your practice papers, you need to stop and recalibrate your approach immediately. To help you avoid that very first mistake regarding terminology and process, I've got a highly effective, actionable memory hack for you. Look, under the pressure of a timed exam, it is so easy to blank on specific technical terms. So create a custom mnemonic using the first letters of key packet switching terms. Things like header, packet, trailer, IP address, sequence number. Maybe something like huge packets travel in seconds. Whatever sticks in your brain. Having a phrase like that locked in your memory ensures that precise terminology is always right at your fingertips. That frees up your mental energy to focus entirely on the analysis and application parts of the question.
Finally, Section 5, Sculpting the Perfect Answer.
Let's bring everything we've talked about together into a strict, time-managed execution matrix. We're going to look at a typical 5-minute allocation for a midway question. Listen closely. In minute 1, you do not write your answer. You deconstruct. You identify the given information in the prompt, decode the command words, and plan your attack. By minute 3, you move to the solve phase. You break your knowledge into those logical steps, the cause and effect we talked about, and you write systematically. Finally, by minute 5, you evaluate. You check the reasonableness of what you just wrote, and you justify your final recommendations. Implementing this strict deconstruct, solve, evaluate pacing completely prevents that dreaded generic fact dump. Why? Because you were spending the first 20% of your time strictly analyzing the scenario before your pen even starts moving.
And during that final evaluate minute, if you really want to secure those absolute top-tier analytical marks, you need to evaluate the quality of your own evidence. You do this by explicitly identifying data limitations in the scenario. Note any underlying assumptions you had to make about the network in your answer. Consider alternative interpretations. Ask yourself, what if circuit switching was actually better for this specific use case? And track how those alternatives would affect your final conclusion. Doing this on paper shows the examiner that you aren't just blindly reciting a textbook. You are thinking and problem solving exactly like a real IT professional.
And that brings us to the end of our strategic breakdown for Section 14.6. So I'm going to leave you with this final provocative question. When you sit down for your very next practice paper, will your answer be a generic, unorganized block of facts, or are you going to use these tools to chip away the noise and deliver a sculpted, context-driven masterpiece? The strategy is entirely in your hands now. Apply the sculptor methodology to your next past paper and just watch your analysis marks transform. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.